Okay, the other half of this lesson involves taking what we're learning today and applying it to problems like the ones we've seen in previous sections. So basically we're taking what we've learned in sections 2 and 3 of this chapter, and now we're applying the Integer Zero Theorem to that. So in example 3 it says graph polynomial g of x equals x cubed minus 7x squared plus 16x minus 12. Now we need to figure out the zeros, the end behavior, all of that stuff in order to get an accurate graph. So let's start with end behavior. The lead term here is x cubed. So since the lead coefficient is positive, the right end behavior is pointing up. Since the degree is odd, it's degree 3, the left end is pointing down. Let's see. Then we would need to figure out the zeros. To do that, we need to apply our new rule. Our constant term is negative 12. That tells us our possible roots. Unfortunately for us, is a rather lengthy list. Could be positive or negative, 1, 2, 3, 4, 6, or 12. So we start looking for one that works. We start with 1, and we run synthetic division using the coefficients from g of x. Again, what we're looking for here is a remainder of 0. So 1 does not work. It's not 0, so we have to try another one. So we run it with negative 1. Again, we're just going to keep running these numbers from this list until we find one that works. We should work from smallest to largest. Boy, that really didn't work. Okay, so that's definitely not it. So we move on, we try 2. And we just keep running till we find one. There we go, there's one that works. Okay, so because 2 works, that tells us that g of x factors into x minus 2, because 2 is the number in the box. And then a trinomial made up of these numbers down here. 1, negative 5, positive 6 would be 1x squared minus 5x plus 6. Now that factors, again, into 2 numbers that multiply to 6 and add to negative 5 would be negative 2 and negative 3, which means g of x can be written as x minus 2 squared times x minus 3, which means we have 2 zeros, x equals 2, with a multiplicity of 2, and x equals 3, with a multiplicity of 1. So again, we know the end behavior. The left end points down, the right end points up. We know that it touches, but does not cross the x-axis at positive 2. And we know that it crosses the x-axis at positive 3. So we're starting low. We come in, we touch at 2, then we cross at 3, head up and off the graph. We have one more example to do here in order to finish up this set of notes. So same idea. Here on the next example, we need to go through this the same way that we have in the previous section. The difference being that they didn't tell us a factor and it's not in factored form. So we're going to have to apply the zero factor theorem and use synthetic division to figure out what the zeros are. So the lead coefficient is positive. Okay, so the lead coefficient is positive, which means that the right end behavior is pointing up. The degree is even, which means the left side is doing the same thing. It is also pointing up. Once again, our constant term is 12, which means our list of possible integer zeros, while rather lengthy, are all of the factors of 12, which would be plus or minus 1, 2, 3, 4, 6, and 12. So we start in at 1, and we try to find a 0. So here we go. 1 comes down, 1 times 1 is 1, that's 5. 5 times 1 is 5, that's negative 4. It's negative 4, add down is negative 20. That is not going to work out for us. That is negative 32, that's not 0. So we go on to negative 1. 1, 4, negative 1, negative 16, negative 12. Here we go. 1 comes down, negative 1 is 3. Negative 3 is negative 4. Positive 4 is negative 12. There we go. That one works. So, g of x factors into x plus 1, because negative 1 is in the box, which means x minus negative 1, which would be x plus 1. And then we have this depressed polynomial, is what this is called, x cubed plus 3x squared minus 4x minus 12. Now, if we did not recognize that that would factor again, we could keep testing zeros with the new depressed polynomial, this one, as our coefficients in synthetic division. However, I recognize x cubed plus 3x squared minus 4x minus 12 can be factored by grouping. There's a pattern to it. So we could take a x squared out of the first two sets of parentheses, which would give us x plus 3. We can take negative 4 out of the second set of parentheses, which would also give us x plus 3, which means that factors into x plus 3 and x squared minus 4. Okay, so this is like side work, as it were. So g of x can be written as x plus 1 times x plus 3 times x squared minus 4. Well, x squared minus 4 is a difference of two perfect squares. That factors again into x plus 2 and x minus 2. So now we have it fully factored. All four factors have a multiplicity of 1, meaning we have zeros at 4 points, all of which are multiplicity 1, which means the graph simply crosses at these 4 points. X equals negative 3, x equals negative 2, x equals negative 1, and x equals positive 2. Okay, so it comes in high, passes through negative 3, through negative 2, through negative 1, through 2, excuse me, back up and off the graph, and we are done. That does it for our notes on this section. Hopefully we can use these to get that assignment started. Thank you for your time.